Hey folks, we're doing worksheet 7.6, looking at solving equations. But you're going to see here that there's going to be some radicals involved with this. We're going to be taking square roots, cube roots, fourth roots, that kind of thing. Remember your solving skills. We're going to take our PEMDAS and we're going to undo things from the bottom up. I'll show you what that looks like in a little bit. So here is x. We're trying to get x by itself. So you got to ask yourself, what's being done to x? It's being fourth rooted. You could also think of this as x to the 1/4 if you want. You do not have to. And that equals 3. So these two lines are equivalent. You can live in radical land or rational exponent land, whatever you want. So the question is, how do we undo the fourth root? Whichever way you want to think of it. Well, we have to take it to the power of 4. So I'll write it here, taking this to the power of 4. So what we do on one side, we have to do on the other. Maybe you do like to see it with rational exponents instead. I'm taking it to the fourth root. I'm taking it to the power of 4, which is the same as 4 over 1. So when you multiply these powers together, because of power to the power you multiply, you end up with x to the 4 over 4, which is the same as x to the 1 power, which is what we've always been trying to solve. We've never actually put that 1 up there, but there is a power of 1 up there. Of course, what we do to one side, we have to do to the other, so we get 3 to the 4th power, which is 81. So there is our final answer. You could plug it in to your calculator, take the fourth root of it, and you'd see that it equals 3. So here, we're going to undo subtracting 9 by adding 9 on each side. So we get negative 3 on the right. And we have the square root of x equals negative 3. So how do we undo square rooting? We square. Make sure you put this in parentheses, folks. When you square that, you get x equals 9. Boom. Number 3, what's being done to x? Well, x is on each side. And luckily for each of them, each of these x's are getting raised to the 1/3 power, or the cube root. So to undo that, we're going to cube it. Now again, what we do to one side, we have to do the other side. And luckily, it's again the cube root over here as well. So when I cube the right side, that's a 3 by the way, folks, it's going to undo this whole radical and cube root. I shouldn't say left, so that was on the left side, but all right. So when I cube root the left side, when I cube the left side, it's going to undo this cube root on the left side. So this whole stuff gets undone. This whole set of stuff. So what's left is 3x minus 13. And again, the luckiness is that because I cubed the left side, I have to cube the right side. And the luckiness is that cubing the right side undoes the cube root on the right side. So our new equation is this. No more radicals, no more exponents. So now it's just a simple linear equation. So x is on both sides. You want to get x to one side. I'm going to subtract 2x off of each side, which leaves me with 1x, or just x, on the left side. And on the right side, again, these are 0. So we have negative 6. So then x is only getting subtracted by 13, so we undo that by adding 13. So it actually turns into a kind of basic linear algebra solving equation once we undo those radicals, and it's not so scary. So I refer to the fact that when we're solving equations, we want to undo our order of operations bottom up. We want to start with the a and the s on the bottom. So let me write PEMDAS really quick. PEMDAS, and let's analyze what's getting done to x here. X is getting added 2 by 2, but that's actually like in parentheses. X is getting plus by 2, and then it's getting square rooted. So I'm going to put the plus 2 next to the p that's in parentheses. Basically, it's tied to that radical. Speaking of radicals, x is getting raised to the 1/2 power, or x is getting square rooted, however you want to think of it. And then we're also subtracting 8 from the x, but that's outside of all of this radical exponent mess. So that goes down here. So now we're going to add 8. So again, we undo things from the bottom up. So I'm going to add 8 first to undo subtracting 8. So we get the square root of x plus 2 equals 7. So I've undone this. Now I have to undo square rooting. And I undo square rooting by squaring. So I'm going to square the left side. That means I have to square the right side of the equal sign. And again, when I square the left side, it undoes the whole square root. So on the left side, I have x plus 2 now. On the right side, when I square 7, I get 49. And now I undo adding 2 by subtracting 2. So I get x equals 47. Zoop. Zoop. Number 5. Oh boy, what's being done to x here? So x is getting, if I make my list, x is getting added 2 by 4. That is outside of the radical, folks, so it's not in parentheses. It's not in that thing, in the radical sign. So I'm going to put plus 4 down here. X is getting multiplied by 3. And x is getting square rooted. So I undo adding 4 first by subtracting 4. So I get 3 times the square root of x equals 6. So next, I undo multiplying by 3 by dividing by 3. So I get the square root of x equals 2. And then next, the square root of x, I undo the square root by squaring. What I do to one side again, I always do to the other. Squaring and square rooting undo each other, so I'm just left with x. X equals whatever 2 squared is, which is 4. Yay! Last one. I'm going to make a list of my order of operations and record what's being done to the variable x. So x is getting added to by 7. But folks, that's in the radical. So it's really clumped with the x. It's in parentheses, essentially. X is getting 4th rooted. X is getting multiplied by 2. And x is getting subtracted by 2 outside of the parentheses. So I'm going to undo subtracting 2 first. So we'll add 2 to each side. So we have 2 times the 4th root. Whoa, that was crazy. I've never seen that before. Did you see that arrow enlarged like that? I don't know how that did it. Equals negative 2 on the right side. I've undone subtracting 2 by adding 2. Now I undo multiplying by 2 by dividing by 2. So I divide the left side by 2. So I have to divide the right side by 2. So this undoes multiplying by 2. So I get the 4th root of x plus 7 equals negative 1. How do we undo the 4th root? We take the power of 4 to the left side to undo the 4th root. But what we do on the left side, we've got to do on the right side. I should put this in parentheses, especially if you're using a calculator. So it's negative 1 to the 4th power. Again, the power of 4 undoes the 4th root, or the 1/4 power. So on the left side, I just have x plus 7. Careful, on the right side, what's negative 1 to the 4th power? It's positive 1. Remember when you take a negative number to an even power, it makes it positive. And then we subtract 7. So we get x equals negative 6. Hey, all right.